Welcome to my garage. Today we're going to do a little experiment just to prove that the charge stored on two capacitors which sit in series with one another store the same amount of charge. That's the same charge irregardless of the value of those capacitors. So I've got this circuit set up here. So I've got my power supply here set to, we'll be changing that, but it's set to 11.2 volts to start with. We've got a series protection resistor of 100 ohms, and then we've got a capacitor here which is 10 microfarads, and then a 47 microfarad capacitor here. Notice that these are both electrolytic capacitors, so we've had to be careful about the orientation and the polarity of those. I've got my multimeter set up over here, which gives us a reading of the voltage that's established across each of these capacitors once we turn it on. Now I'm going to repeat this experiment 3 times so that we've got a different value, so that we've got different potential differences established across each of these capacitors, and then I'll do some calculations and you'll be able to see, hopefully, that within the margin of error and uncertainty of this experiment that we've got we have the same charge stored on both of these capacitors. Alright, so let's start off then. So we'll just start this off with a value of, I've got 11.3 volts, and you can see that the current is going to be falling down as these capacitors charge up. I think in the same way as we've seen before that there's a leakage current possibly, or more likely that there's a systematic error on here. So let's measure the potential difference across the first capacitor, and let's measure this way round. Please excuse the cat meowing in the background. So if you can have a look at the voltmeter, please, over here. So this gives us a value of 8.7 volts and a value of 2.5. So I'm just going to write that down. So I've got 8.7 and 2.5. Now I'm going to adjust the voltage from the power supply, so let's take that right down to about there. Doesn't really matter what we're measuring here. And then I'm going to measure these again. So we've got a value of 6.4 and a value of 2.1. So let's record those. 6.4, 2.1, and then let's take this down to around about 4.7 and record the same values again. So we've got a value of 3.4 and 1.4. 3.4, 1.4. Okay, so now what we need to do is we've done with the experiment, so we'll perform some calculations here. So we want the charge stored by each of these capacitors, and we know that charge is equal to the capacitance times by the potential difference. So here we've got 10 microfarads, so that's 10, 1 to the minus 6, 10 times 10 to the minus 6. We're going to multiply that by potential difference, so that's 8.7. So that gives us 8.7 times 10 to the minus 5. Hopefully, the light's not too bad. 8.7 times 10 to the minus 5. Coulombs. And then we've got 47 times 10 to the minus 6. Oops. 10 to the minus 6 times by 2.5, which gives us this value 1.2 times 10 to the minus 4. Okay, let's do the next row. So we've got 10 microfarads times by 6.4 gives us a value of 6.4 times 10 to the minus 5. the next one. 47 times 2.1, 9.9 times 10 to the minus 5. And then the final row, so we've got 10 microfarads times by 3.4, so that gives us 3.4 times 10 to the minus 5. And finally 47 microfarads times 1.4 to give us a value of 6.6 times 10 to the minus 5. Okay, so if we can now just have a look at the table. So we have got, so within the limit of error on this experiment, what we should be seeing is these pairs of values should be similar to each other. They should be identical. This one is definitely looking higher all the way across. 9.9 compared with 6.4, 6.6 compared with 3.4, 12 compared with 8.7, but we're not a million miles off. Okay, and there we go. Job done.